All right, so the project is about an alternate water supply scheme, and it's using the superficial aquifer at Port Coogee. It's a project, I suppose, that it's been around for many years. I think Bruce has been on it since he was 12, and it's been contentious throughout the years, and I suppose recently it accumulated in the developer being Australand winning a Urban Development Institute of Australia award for development over 250 lots, and also for the Environmental Excellence Award. It also won the President's Award for the UDIA WA chapter. And just last Friday night, I had the pleasure of attending the national conference, and Port Coogee won the Environmental Excellence nationally. So it's very good for a developer to obviously win these awards, but it's a recognition for a project that was difficult to conceive, and it's a recognition, I suppose, Bruce, of predominantly the scheme. So, when Jim asked me to present on a topic, I thought about Port Coogee and the alternate water supply scheme and how it was relevant to stormwater harvesting in the workshop we were having today. I suppose I looked through, a lot of the definitions of stormwater and the definitions of stormwater harvesting, and I suppose what I pulled out was towards a water sensitive city document by DOW. The term stormwater includes both surface water runoff and groundwater intercepted by drains. This project, which we'll go into a little bit more detail in a second, is an interception drain in a shallow groundwater in the superficial aquifer, which intercepts the superficial aquifer, which intercepts groundwater that is, surface water and stormwater that's been infiltrated up the catchment. I suppose the project in general is relevant on what we've been talking about this morning and this afternoon with water harvesting and water efficiency. So Port Coogee, for some of you who may not know, it's about 5 km south of here. It's a residential and marina development, as you can see, and it's within the city of Coburn. The proposed estate was assessed by the EPA in 2002 after going through a rigorous conceptual design phase, and I suppose a lot of political lobbying as well at the same time. And the Metropolitan Regional Scheme Amendment was endorsed by the state government in 2005. And Brett, it's in your area, Peel Quinana, just in case you didn't know. Okay.
Thanks, Sean.
You're welcome. You're welcome. So this is an aerial photograph from I think probably mid-90s, and it just shows the area as it used to be. It's a pretty contentious area. It was an area that was used for heavy industry and some toxic industries from I think the early 1900s until the mid-80s, until the 90s, until it was changed into what it is today. It had anything from tanneries, fellmongers, edible oil plants, Coogee chemicals were there. It was a nasty enough area, just on either side of Coburn Road and a couple of other roads heading east. So that's obviously a nice comparison. Background to the project, I suppose, and a background especially to the alternate water supply scheme was that it had to go through a rigorous environmental assessment process, and the EPA were very interested in it at the time. Investigations during the EIA process identified that there was significant elevated nutrient concentrations in the groundwater in the region, not just in the local area due to the historical land use, but also to do with the Spearwood area, the significant market gardens area, in this location here, and I think Spearwood and some of Hammy Hill was unsewered back in the 60s and 70s when it first became developable. So there's a significant plume of nutrient-rich groundwater flowing in a westerly direction towards the Owen anchorage and the Coburn Sound itself, and naturally enough it would go into any enclosed water body that the developer was proposing at the time. And the impacts of nutrient-rich groundwater are probably well documented, well known to everybody. It can have a significant impact and stimulate algal growth. Naturally enough, the sources have been removed on unsewered areas in the metropolitan region are pretty much gone now, and the market garden areas have been, I suppose, disused for many years. So the alternate water supply scheme and the abstraction of groundwater had significant environmental drivers behind it. It's not just a water efficiency, water conservation project. There's a significant environmental driver. The Coburn Sound, since the 60s, it was well known that probably the excessive nutrients from inland were contributing to the seagrass decline in the Sound. and some of you may be old enough, and certainly Bruce is old enough to remember the Jervis Bay blooms back in the 90s. And that's just about 4 k's south of Port Coogee. So it was relevant at the time when the concepts and the political lobbying were going into the project that there was significant environmental impact known to the developers and to the local agencies. So the studies confirmed, there was groundwater monitoring, groundwater modelling, groundwater investigations, stormwater investigations, contaminated sites investigations, and they all pointed towards that there needed to be a reduction in groundwater flow and a reduction in the load of nutrients that would be entering into any marina in the area. So the groundwater flow modelling was done in conjunction with hydrodynamic modelling of the marina, and it concluded that around 90% reduction in the groundwater flow to that marina was required so that a development of a marina could go ahead without causing algal blooms. Okay, so the environmental drivers are there. This is more of a slide on the conceptual design, which was the solution to the problem. It was decided that a subsurface permeable cutoff drain was probably the most practical solution, and it would intercept the groundwater across the length of the marina. The GID, as it was known, the groundwater interception drain, was placed immediately inland of that water body, and it was placed with the designed effect of abstracting sufficient volumes of groundwater so that it would lower the water table and thus reduce the hydraulic gradient going towards that marina and reduce the flow of nutrients, I suppose, into the marina predominantly. The flow model was done in ModFlow, actually, so it's relevant to someone who talked earlier. It calculated that you needed a reduction of about 25 centimetres, and that would achieve the 90% reduction of flow to the marina. And reducing 25 centimetres across a 900 metre long interception drain required the abstraction of 7,400 cubic metres a day, which is, I think, around about 86 litres a second. So that's the concept. Don't know where the pointer's gone, but it doesn't really matter. That's the concept design itself. So the marina would be out here. The receptor, which is the marina, and the source would be on the other side, further up gradient. The dashed line is the existing hydraulic gradient towards a marina. The GID is the middle, unusual looking thing, and that's essentially the designed effect. Would be to reduce the groundwater in that local area, causing a relatively light cone of depression, but reducing that hydraulic grade between the marina and the drain, so reducing the groundwater flow. So the key objectives of the GID, the environmental driver, it's going back to that environmental drivers, is facilitating a significant reduction in the nutrient loads to the marina and to the Owen anchorage itself. I got it, no need to worry, panic averted, it's there. So it's facilitating that reduction, as I said, of the nutrient loads to the marina and the Owen anchorage and the Coburn Sound itself, and that the abstracted stormwater and the abstracted superficial groundwater would provide that sustainable, non-potable water supply for the development. And that non-potable supply would not just be to lot owners, but it would also be obviously across the POS and streetscape for the development. The significant challenges obviously to this project, you can imagine a 900 metre long cut-off drain. I think Bruce is going to shock you with some figures and some photos. Logistically challenging, challenging particularly because of the abstraction rate. 7,400 cubic metres a day is a hell of a lot of water, and it would far exceed the irrigation water requirements for any development and for an alternate water supply scheme to individual lot owners. So, the excess of abstracted groundwater was always a factor, and re-injection was the only logical thing to be done. Obviously, significant water quality considerations as well for this site. I spoke earlier about the toxic industry. Obviously, practices in the 1900s, in the early 1900s, weren't what they are today, and there was significant contamination issues, significant groundwater contamination plumes of arsenic, chromium, TPH. And a lot of other things associated with tanneries and fellmongers and oil plants. So, extensive groundwater monitoring was done of the development itself, and then as well of the regional area. Just a comparison of those nutrients in the groundwater was also really important. Detailed contaminated sites investigations had to be done, and they were rigorous, and they were in the transitional zone between the new contaminated sites management series, so there was an awful lot of time delays as well. And then the key challenge as well was naturally the detailed design of any groundwater abstraction system, in a superficial aquifer. It's challenging. receptors to be considered, not just on site, but upgradient ecosystems that require ecological water requirements. And obviously, then when you're close to the ocean, the upconing of the sail and wedge and drawing in salt water is obviously a massive consideration if you're going to be using this water for irrigation. Key challenges, I suppose, that I'll leave to Bruce to kind of further elaborate is the detailed engineering design of this system. It was a multifunctioning system. It need to accommodate and incorporate variability in its delivery and abstraction volumes. And, it's really expensive infrastructure to put in place, so you need to get it right from the word go. And the staging of construction and then the staging of dewatering was also a significant challenge. And I touched on water quality monitoring a while ago. I suppose this is just an image that, I've tried to put up there just to show the volume of water that was, or the number of locations that had to be monitored. That's just on the site. And the regional groundwater monitoring that was done as well was also extensive, through the wind database, the wind bores, and through bores that were put in by the client. But that just shows the number of bores that were monitored. And monitoring is continuing today through the licensing requirements, whether that's through DOH or through the DOW's license to abstract water. So the alternate water supply scheme itself, it uses this groundwater interception drain, as I mentioned, which will be further elaborated on by Bruce. It uses that abstraction system to supply non-potable water supply to the development, to lot owners, and to POS. It's a good example, I suppose, of urban development project incorporating these water efficiencies that we've been talking about for so many years. I probably won't go into approvals too much, and I'm happy to take questions on it, I suppose, a little bit later on in the plenary session, workshop session. But naturally enough, a system of this type, it wasn't necessarily standard practice, in the 90s when the concepts were thought of, and certainly not in the last 10 years. And it had, significant hurdles in terms of approvals. There was an exemption given on the water services operating license, and that was given by DOW, so there was no ERA license to go through like a lot of other projects are probably thinking about doing right now. And the GID system itself, the concept design was approved by the Minister for the Environment through the environmental review process, which was then, it was also approved by the DOW, DEC and DOH at the time. The DOH has approved the alternate water supply scheme subject to a number of conditions, so they're happy for that non-potable supply scheme to go ahead in terms of the water quality that we're finding right now. And the DOW has granted us a 5C license to abstract and re-inject that water. So this is probably, you all want to know what it actually looks like. This is the development of how it will look, and the GID itself, the 900 metre long interception drain, is that blue line running right through the middle of the development, which is 100 metres back from the original foreshore area. We have two pumping stations, which abstract the groundwater, or the intercepted water in this drain. And in tandem with those two pumping stations are two saline intrusion monitoring bores with electronic detectors in them. So, naturally enough, and you'll get to see some beautiful pictures, but the volume of water required for an alternate water supply scheme and for irrigation of a development needs to be stored somewhere. So there's a significant storage tank there, 8,500 cubic meters. And then there's a 2 kilometre long re-injection pipeline to the north of the development to re-inject this nutrient-rich groundwater to an environment that is less sensitive. It's further away from the Coburn Sound in Owen Anchorage, and it's more exposed to the ocean. It's to the north of Garden Island essentially, and it's subject to a lot more dilution. So we've got 5 re-injection bores 2 k's north of the development, further towards Fremantle. That kind of finishes a lot of the concepts and a lot of the environmental setting. I'm just going to hand over to Bruce now, and he's going to talk a little bit more of the detailed engineering and construction.
Thanks, Shane. Good afternoon. I won't crack any jokes about Shane's age. This is just a bit more of a detail of the actual interception drain in the middle of the estate. The long section at the bottom gives you an idea. The drain is actually situated between RL-1 and RL-2, and in some cases that leads it to be up to 9 metres deep. When we started this project, we realised that the actual system itself is an asset. It's an asset at the end of the day. They'll be properly built. have the associated licences with it, and therefore it could be either owned by our client, passed into the City of Coburn, or it could even be on-sold to some other party. So we set out to try and make a proper, robust engineering system that will last the distance. So at the time, there was little in Australian standards about construction materials, so we set out to use typical materials in use in WA, and mostly we've copied the Water Corporation's potable standards for pipes, thrust blocks, valves and so on. This also meant that there was a pool of trained people who have their pipe laying accreditation, who know how to lay all these systems and fix them up. So ongoing, it makes those matters much easier and much cheaper. We've used similar testing and QA procedures to the Water Corporation, so that again there's a bunch of people with the right valves, equipment and knowledge to know how to test pipelines, test systems, run pumps and check them all out. One of the key issues in the construction is the Water Corp and Department of Health were, shall I say, paranoid about this, is cross-connection. Any secondary water system is a terrible risk of cross-connection and people not getting proper water to drink. So our pipes are on the opposite side of the road to the potable system. Our connections to lots are on the opposite side of the lots. And there is an Australian standard for pipe materials, and for non-potable systems it's lilac. All our pipes are lilac, all our fittings are painted lilac. There's warning signs and information that separate it. So someone coming along, if they're competent, should know that's a potable water system and that's a non-potable system. So we based it on Water Corp potable standards as common. We've taken the extraction pump stations and we've used the Water Corp's automatic undertended sewer pump station design, that is 2 pumps that operate alternatively, and their control systems use similar components. The delivery pump sets, we've mimicked Water Corp booster pump stations, and there's not that many of them in Perth, but there are. And the last thing that we really considered was that in our information package to customers, we needed to tell them about the system and some of their responsibilities. The system's pretty big. It's somewhere about $11.5 million worth. I mean, it's finished. We couldn't build it all in one go, and because of the way the project program was structured, it's been built in different pieces over different times. So the first piece that was built was the GID, and it was built during bulk earthworks. And one of the reasons that was done is that we had some major services to relocate out of Old Coburn Road, 150 high pressure gas main, 600 sewer pressure main, a 200 mil potable water main and a 22 kV power system. The GID is under the middle of Orsino Boulevard, our north-south road, right under the middle of the median, and we didn't want to come back at a later time and dig a 6 metre deep trench in the middle of a road with all this other fruit around. So we put that in the bulk earthworks contract, which is why when you look at some of the photos, the surface looks a bit ratty, but that's how it was. The ground was pretty good to us. It was a structured layered system. We had about 2 metres of firm limestone on the top. We had about 1.5 metre layer of shell and sand, which was quite friable, but it was dry. And then we went back into limestone, and we never got out the bottom of the limestone. So even where we got to the bottom of the sewer pump stations that were 2 metres deeper, we were still in limestone, which meant that the shoring and so on the main, we didn't need to shore it. We could, and you can see in the middle of the photo, this is an early part of the drain in late 2005, and we were just working across the middle of the site, building it. One of the things, of course, we needed an extraction licence, and so we had to manage the dewatered water on site. And with bulk earthworks that you can see occurring in the bottom here, we had 2 areas in the northern part of the site where we built temporary dams. The middle part of the drain, in this part we were dewatering at the rate of 290 litres per second. And just to put that in context for you, we were able to turn the pumps on at 6 in the morning, have the trench dry to work at 7 o'clock and turn them off again at 5 o'clock at night, so we weren't running pumps overnight. And that's about 11,500 cubic metres of water a day we were pulling out of that and having to temporarily store. It was up the hill. We think it was soaking and coming back on us. We had little choice to do with that. So here's another shot of the drain. At one particular spot, you'll see that the combination of pumps, and we've constructed that. The advantage of the drain was that we had a bountiful supply of water for construction. So we were able to get an exemption from the City of Coburn for their dust moratorium through 3 summers, and we were able to draw as much water as we wanted. We ran 4 and 5 water carts flat out each day, and so we were able to continue earthworks on a large scale right through hot summers. A few details of the drain: 900 metres long, about 100 metre inland. It's a straight 375 rubber ring joint reinforced concrete pipe laid without rubber rings, open joints, encased in crushed rock, and a GFX tile wrapped up and closed up again. For the engineers amongst you, if you think of a 375 diameter pipe, at one stage we had that into a partly built structure. It was flowing full, straight across the structure and hitting the wall on the other side. That's how much water we had in the middle. It has 2 abstraction pump stations. I've got a control picture. They're same as Watercorp sewer pump stations, larger shell and an access chimney. They're right in the middle of the road under the median. And they moved around a little bit in the design because our client didn't want them next to a building because it might affect footings, and he didn't want to give a separate bit of land for them, and so they've ended up under the median of the road. The second thing that came along was the storage tank, and strangely enough this was driven because it's under the open space in stage 1. So to finish stage 1 we needed to build the tank. It's 8,500 metres capacity, and that's based on a 2.5 day supply if the whole system was operating fully as we expected. And it was always the view that if the interception drain pump stations failed or we couldn't get water, there's at least 2.5 days to give the operator a chance to obtain replacement pumps or fix some alternative. And in actual fact it would give you more, because a smart operator would go around to all the users and say cut your use by half to give us a bit more time to fix it. It's a semicircular reinforced concrete tank. The floor and walls are in situ with water stops and everything else, and the top was precast, and then over the top of that there's a screed slab, and there's about 1 metre in soil, and if you go in and out it's an open space with picnic places for everyone to take advantage of. So it was driven by stage 1. Our client needed to sell some lots because about this time of the project he had something like $15 million out in expenditure and needed a bit of income. So the pumping infrastructure, the top shows the control cabinets in one of the extraction pump stations. In the median, all the other electric valves, flow meters are all in pits below ground, and that's all you've got. There's 2 pumps in each well, so each one is only related at 43 litres a second, and a pump runs in each one continuously to give us our 87 litres a second that we need. The actual delivery pumps to both the non-potable lot supply and to the open space. There's 2 identical sets of equipment, and this is a picture of one of them. They're pretty standard booster pumps. The small front pump in the front is what we call a kicker pump. It keeps the system pressurised, so if someone turns on a tap, the drop-in pressure starts to turn on the other pumps, and as more draw is made, the other pumps cut in until they reach optimum design capacity. This is a bit early. The pump station now has been kitted out with a ventilation system, so we don't have to derate the pumps through heat, and the pumps are tucked in under the tank to try and suppress noise. So the system was built to be flexible. We didn't know whether the extraction rate along the 900 metre length of the drain would be uniform or would be varied. We didn't know whether we would need to run one extraction pump station a bit more than the other to try and balance that. And we didn't know in our delivery whether the actual scheme we'd designed would actually end up built. And so right now at the moment it's designed for 720 residential lots and 800 apartments, and there's about 350 lots built and perhaps about 120 occupied. So there's a lot of variability in all the control system, and it's all programmable logic controlled. So the operator will be able to adjust the system to suit the demand at any given time or to suit any operational function that comes up during the course. It sends fault messages by wireless technology to a remote station, and because of our agreement with the City of Coburn, that will be in the City of Coburn's office. There will be a computer on a desk. Next door will be an operations manual where it says if you get fault message XYZ, it means this, go and do this. If that doesn't work, call somebody out. And we'll have all the as-constructed documentation and everything all together in one place so someone can properly operate the system for perpetuity. The system also gathers data for annual reporting against our licence. We have 2 flow meters, so we can measure the amount of water that we're pumping all year, every year against our licence, and we can report on that. City of Cockburn have been really good through this whole process, and they had agreed to become the operator after handover. And the thing we've talked to them about, they've said, well, we don't have anyone who fixes pipelines. But in WA, there's a good pool of skilled companies that contract services. Watercorp contracts its maintenance out to people. So the City of Cockburn will end up with some sort of annual service contract which they can have to call and come and carry out any repairs that are necessary. And last but not least, we're still working hard to make sure that we have no cross-connection. I think it's just me to finish now, but I do want to say something about the City of Cockburn because it is a local government engineers conference. This project has, for me, been a remarkable cooperative effort. City of Cockburn have really been terrific. We've had monthly coordination meetings with their senior technical directors and staff as necessary. The staff have worked in with us, and including the seawalls and breakwaters, which were completely new to them. This system is new to them and different, and they've been really good in saying the project team's doing a good job, we'll have faith, and we work together to get where we are. So I know we normally beat local government over the head, but in this case they have been really terrific. To you?
Yeah, stole my thunder on City of Cockburn.
Oh, you can say it again.
Yeah, I'll say it again. Look, just in terms of governance, it's obviously an alternate water supply scheme, supplying water. I mentioned before it doesn't have an ERA licence. It does, however, need an operator in perpetuity. The studies undertaken on behalf of the developer to business cases and scenarios which operator could take it on, who wanted to take it on, how much would it cost. The City of Cockburn agreed with that Port Catherine Developments, which is a subsidiary company of Australand Development, would manage and maintain the marina, the GID system itself and the alternate water supply scheme for a set period until handover to the City of Cockburn. And so they've been, as Bruce said, they've been really good in facilitating that. Obviously, they understand that it is a good development within their city boundaries. And so the city entered into that facilitation agreement with PCD and Australand. So just in conclusion, the system, the alternate water supply system and the GID provides a net benefit to the Cockburn Sound and Owen Anchorage. The system intercepts superficial groundwater and infiltrated stormwater from further up the catchment and further up the development. And it intercepts that superficial groundwater without upconing of the saline wedge or creating a drawdown impact on any ecological receptors. There is an environmental driver behind the system. And water conservation driver is probably a separate driver to the environmental driver that was behind the concept design. The development of this type of system did create a large quantity of water to be used in a sustainable water supply for irrigation and non-potable water supply for lots. And it did reduce demand across this development, so across 850 lots or 720 lots and 800 apartments, which is creating brighter futures as the IPWEA conference is all about. And then, Bruce slightly mentioned how much it probably costs to construct this system and operate this system. Then you not necessarily construct this system if you just have a water conservation goal. You construct this system if you have that environmental driver, whether it be Hillary's, whether it be Jervis Bay or wherever. And just a little bit on the sustainability. In terms of 7,400 cubic meters a day, that equates to over the annual, I think it equates to almost 2 gigalitres. So if Brett from the town of Cambridge wants to come and take all the water and save us re-injecting it, then we'll float a pipe out, bring it back in, whatever you want to do. But yeah, look, 2 gigalitres I think equates to almost 27 hectares of POS, or could provide a non-potable supply for in the order of 18,000 lots or households, dwellings. So significant volume of water. That the City of Cockburn will inherit, and I know that the City of Cockburn are having issues at the moment with complying with their groundwater superficial aquifer licensing. So there is a volume of water that they're cognizant of, and obviously in their facilitation agreement they were cognizant of that as well, and they will have a significant supply of water. So yeah, that's the end of the presentation.